Hey everyone, good to see you. We are starting our new unit on exponential and logarithmic functions today. And today we're going to talk about exponential growth and decay. I'm going to just kind of give you a quick little overview, but I really want you to go to the online textbook and watch those videos because they're really good. But I'll just kind of give you sort of the basics, a little bit of a precursor. And stay tuned because your first task in the holiday home stretch coming up in this video, so stay tuned. Alright, so we'll just get right into it. Exponential functions, it is something that you've seen before. Whenever you see a function in the form of y is equal to a times b to the x, and these letters are somewhat generic. They might use different letters and different things, but that is exponential growth or exponential decay. And the way you can tell the difference is looking at this b value. If this b value, if b is greater than 1, then you have growth. If b is between 0 and 1, so say b is 1/2, then you have decay. So it's really easy when you're looking at an equation to determine whether or not it's growth or decay. So for example, if I have y is equal to 2 to the x, right? That's exponential growth because that number that it has the exponent is greater than 1. Likewise, if I had y is equal to 0.75 to the x, right, that's decay because this number here is between 0 and 1. Really easy to tell the difference between the two. Okay, let's talk a little bit about the graphs of exponential growth and decay. And I'm doing this all kind of basic. Really just giving you a sketch, just doing it by hand to kind of give you the general overview. So a times b to the x is the general form. When you have a graph of an exponential function, it looks like this. So here's the point 0, 1, and our graph goes through that point. So what happens is it increases little, goes through that point, and then it kind of shoots up. That is exponential. This is growth. That's what exponential growth looks like. It always is going to go through that point 0, 1. Now, your domain, right? I can plug any value I want in here for x. But look at your graph. It never goes below 0 in the y direction. So real quick, your domain is that x can be anything. So it's a set of it's an element of the set of real numbers. And your range is that y has to be greater than 0. Likewise, if I'm talking about exponential decay, my graph still goes through that point 0, 1, but instead of having this shape, it ends up looking like this, where it goes, sound effects and all, people. Right, so it ends up going like this. It's getting smaller and smaller and smaller. This is decay. This domain and the range are the same, right? The domain, I can plug any value I want in for x, and my range is still going to be y is greater than 0. This equation is the same for both growth and decay. It's just a matter of what that b value is. Remember, for growth, b is going to be greater than 1. For decay, b is going to be less than 1. So that's the idea behind those graphs. Now, what's great about this stuff is you can do it all in the calculator. So let me just show you quickly on the calculator what you can do with this. If you go to y equals, and let's do, 1.5, right? So that's going to be exponential growth because that's greater than 1. And I'm going to do that to the x power. Okay, so that's going to be 1.5 to the x. if I were to graph that, you'll see that it has that general shape, basically the shape that we did right here. Okay, it looks like it's touching the x-axis, but it's not. Right? It never actually equals 0, so that's the general shape. You can always go to the table of values. If you just hit second graph, it'll take you to the table of values. So whenever it's asking you to plot, and it does this on the assignment, right? It asks you to go ahead and go ahead and graph the exponential functions. Put it in your calculator, hit second graph, make a small table, and then plot those points. Okay, it's very straightforward how to go about doing that. So I just wanted to go over that real quick. Now, another important thing about the exponential growth and exponential decay is that letter you saw in there, y equals a times b to the x. Right? This is your growth or decay rate, but this is your initial amount or starting amount. Sometimes they call it your principal amount when you're talking about money, right? So let's say, for example, you buy a house and you purchase the house for, I don't know, $47,000. And the house appreciates, meaning it gains value each year. Depreciate means it loses value each year. So let's say your house appreciates. Now, it's kind of a funny sounding word. Appreciates at a rate of 6% per year. And so my question is, what will your house be worth in 20 years? Now, this 6% comes in with that B value. You always start with B is equal to 1 because B represents the percentage of things that you have. So when you start, you have 100%. So if something is gaining in value, then you're getting more than 100%. If something is decreasing in value, then you're getting less than 100%. So if you kind of think of it that way, I think it makes it a little bit easier. If I were to convert this percentage into a decimal, that would be the same as 0.06. And if you think of your B value, you can almost think of your B value as starting at 100%. So if I have 100% to start with and I add 6% to that, I end up with 106% at the end of 1 year, right? Because I started with the whole value and I added 6% because I appreciated. So now I have 106%. If I were to write that as a decimal, that would be 1.06. That right there is my B value. So if I were to put this into my equation, 47,000 is my starting amount. My B value is 1.06. X in all of these problems represents time. And so I want to know what happens, what my house is going to be worth in 20 years. So I'm going to put 20 in there. And so if I go to my calculator and I just literally plug this in exactly as it's written, I've got 47,000 times, put parentheses, 1.06, close my parentheses, and raise that to the 20th power. I did this all in one step, okay? And if I press enter, that tells me in 20 years my house is going to be worth $150,735, roughly, if I were to round to the nearest dollar. It was $150,735. That's what it would be worth in 20 years if it were to appreciate at 6%. Okay, so that's the idea behind exponential growth. Exponential decay works the same way. If I had a situation where I had decay, so let's say you're talking about your car depreciates. I mean, you may have heard the term, oh, it depreciated as soon as I drove it off the lot. People always say stuff like that. So let's say your car costs, when you bought it, $20,000, and it depreciates 20% per year. What will it be worth after 3 years? Okay, 20% per year. So that means I started with 100% and I'm losing 20% each year. So now I'm at 80%. If I were to write that as a decimal, that's 0.8, and that is my B value. So if I plug into my formula, I have y is equal to my starting amount, which is 20,000. My B value is 0.8, and my x is 3. X is always your time. If I were to go ahead and plug that into my calculator, 20,000 times 0.80. You don't have to put the 0 in, but some people like to put it in exactly as it's written. Raised to the 3rd power. So after 3 years, my car is only worth $10,240. Okay, so that's the idea behind exponential growth, exponential decay. Now, here is your very first task in the holiday home stretch. So listen carefully, because I'm not writing it all down, so you have to listen. Here is task number 1. You have the opportunity to work for a company for the next month. Okay? So, it's December 1st. You're going to work for 30 days. So you're going to work till December 30th. And you work every single day. And here is the stipulation. On your very first day, so on day 1, you are making your entire salary for day 1. Are you ready? Your entire salary is 2 cents. Every day after that, your salary doubles. So, day 2, your salary will be 4 cents. Day 3, your salary will be 8 cents. Day 4, your salary is 16 cents. So, day 5, let's go through 1 week. Day 5, you're making 32 cents. Day 6, you're making 64 cents. And day 7, you've made $1.28. So at the end of 1 week, if you add all of these up, so if you add these together, that was your salary, your total earnings at the end of 1 week. This is your daily earnings, but when you add them all up, that's your total earnings. How much money will you make on day 30? So how much money will you be making on day 30? And how much money will you make total for the month? And I do not want you to do it out the way that we just did it. You could do it out by hand, but I don't want you to do it that way. I want you to think about exponential growth and how you could do that. So, how are you going to do it? I want you to think about that. I'll give you another little hint tomorrow. And I will tell you this is due at the end of the week. Okay, I'll give you another little hint tomorrow though, but I want you to start thinking about that. That's the first task. More info to come on that. Have a great day, everybody. Another video for you tomorrow. Take care, folks. Bye-bye.